Hi, my name is Alvin from Team 7. Today I'm going to talk about the software design document for our Team 7. We begin with our content list. We have system overview, system architecture and component design, robot design rationale, data design, design details, and human interface design. We start with our system overview. Firstly, we have our hardware components. We use ultrasonic sensor to detect obstacles. We use our color sensor to detect deposits, boundaries, and the corners. Then we use our motors to do our robot movement and dropping token as well. Next, we have our software components. We have our robot software, which serves as an interface between the GUI and the robot itself, and it provides utility functions such as movement and color detections. Then we have our GUI software, which provides the user interface to the Mesa robot system, and it is running on Java. Next, we talk about system architecture and components design. We use client and server architecture. Our operator, which acts as the client, will be able to start or stop mapping process, can toggle auto or manual mode, and move up or down and turn left and right, and etc. Our robot, which acts as the server, is able to perform the actual movement and able to mark and identify the deposits as well. Next, we talk about a robot design rationale. We need to think about the robot size. We need to be able to create the robot such as that it is not too big and compact enough to perform all the mapping process. Next, we talk about the grid accuracy. We need to ensure that our robot is able to map and process the map efficiently. So we need to ensure that the sensor itself is actually directly below the robot, such as during the rotation, it is not moving out of the place. Next, we talk about the boundary detection. We need to ensure that our robot is actually not out of bound when it is detecting the boundary itself. And lastly, we talk about the token placement. We have to ensure that our robot itself is able to place the token in the deposit. Hence, we craft our robot to have a much more simpler way of placing the tokens by using the rotation. Next, we talk about the data design. We have our map, which is actually a list of points. A point itself is an x and y coordinate. And we have an area, which is a list of points that represents a certain object, like deposit, operation base, and no-go zone. And then we have our corners, which is actually just 4 points at the corner of the map. Then we talk about our use case diagram. Our use case diagram have two actors, the operators and the robot. Operators is able to perform things like send control command, toggle auto or manual mode, load map, and save map, while the robot itself is able to follow the commands that is sent by the operator, and it is able to map location, avoid obstacles, and dropping tokens as well. Next, we have our class diagram. Our class diagram actually consists of 5 major class groups. First is the robot controller class, which will act as the interface between the GUI and the robot itself. Then the robot class, which is actually an implementation of the robot itself that does things like moving the robot and turning the robot as well. We have our GUI class, which will perform things like the GUI creation and as well as all the buttons as well. Next, we have our AI class, which will perform all the mapping and heavy processes. Then we have our map class, which will represent the map of the map itself. Next, we have our state diagram. This is the state diagram of a manual mode. Initially, it is at a disconnected state. When we press connect, it will go to the connect mode, and we select the manual mode, it will go to a ready mode. From here on, when we press up or down button, it will go to the movement state. Next, if we click on left or right, it will go to a rotation state. Then we also have a go to base state as well. Do note that for every of the states, when we press disconnect, it will go to disconnect state. And this is our state diagram for our auto mode. Initially, it is also in a disconnected state. When we press connect, it will go to a connect state. And then when you select auto mode, it will go to ready state. From here on, it can go to boundary mapping, zigzag mapping, or even go to base. It depends on what is already available at our map. If it has finished the boundary mapping, then it will jump directly to zigzag mapping. And it is the same. When we press on disconnect button, it will go to disconnect state. Next, we have our interaction diagram. This is a quite simple diagram. It represents our interaction between the operator, the system, and the robot itself. For instance, when the operator clicks on connect button, the GUI system will perform a connect function to the robot, and the robot will respond back with a connection established, and we will display the connected to Mesa robot wrapping robot system. And it works the same as when they press the arrow button. It will call a movement function, and when it has finished, we will display the movement has been finished. It is the same as the disconnect button as well. When we press it, it will call disconnect button, and it will close all the ports, and when the connection has ended, we will display it out to the user. Lastly, we have our human interface design. So firstly, I will show you, this is our connection panel. It will show the connection status to the robot and a connect and disconnect button. We have our controller, which when we press up, down, or left or right, it will perform a movement and rotation. When we press start on auto mode, it will run the mapping manual automatically. Then we have our robot main controller, which we can set our initial location, move to location, and set no-go zone, and toggling auto and manual mode and go back to base. This is where we will display our map, and this is our logs. Thank you so much for watching.